Welcome to the Lab 2 guide for DAT22103. In this lab, we will be exploring cloud infrastructure, access paths, and storage concepts through a local simulation. The purpose of this lab is to help you understand the foundation of cloud infrastructure by examining data centers, regions, virtual machines, and storage systems in practice. We will use the VMware Ubuntu environment installed in Lab 1 for these simulations, mirroring concepts found in AWS, Azure, and Google Cloud. By the end of this lab, you will be able to clearly explain how virtualization reflects real cloud infrastructure. You will identify the hardware characteristics of your virtual machine and compare them with actual cloud servers. You will also simulate cloud access using Linux users and permissions, and demonstrate the differences between object, block, and file storage. In addition, you will understand how reliability, regions, and availability zones work in real cloud systems. Finally, you will connect the theories from Chapter 2 to practical simulations on your own machine. Now let us look at Task 1, which is about identifying your VM hardware. In this task, you run 3 commands in the Ubuntu terminal: lscpu, freenetsh, and dfh. When you type lscpu, the system shows information about the CPU, including the model and the number of virtual CPUs, or vCPUs. In cloud computing, this is similar to choosing how many CPUs your cloud server should have. For example, when you launch an EC2 instance in AWS, you select an instance type like 2 vCPU or 4 vCPU. That selection determines how much processing power your application will get. Next, when you type free-h, the system shows how much RAM is available and how much is being used. In real cloud environments, RAM affects how many users your application can handle at the same time. For example, an online banking system needs enough memory to handle many transactions smoothly. Then, when you type dfh, the system shows your disk size and how much storage is free. In cloud systems, this is like checking how much storage space your virtual machine has for installing applications, storing data, or saving logs. Think of your Ubuntu VM as a small cloud server running inside a data center. Your laptop acts as the physical server, and your VM acts like a cloud instance. By checking CPU, RAM, and disk, you are learning how cloud providers allocate and manage computing resources for real-world applications. In this task, you open VMware Workstation Player and check your VM hardware settings. You will look at the number of processors, the amount of RAM, the disk size, and the network type, whether it is NAT or bridged. VMware acts as a hypervisor. A hypervisor is software that divides one physical computer into multiple virtual machines. In this case, your laptop is the physical server, and Ubuntu is the virtual machine running on top of it. When you adjust the number of processors or change the RAM size in VMware, you are deciding how many resources your VM can use. This is very similar to what happens in real cloud platforms. For example, in AWS, when you launch an EC2 instance, you choose an instance type, such as 2 vCPU and 4 GB RAM. In Microsoft Azure, you select a VM size with specific CPU and memory. That selection determines the performance of your cloud server. The network type, such as NAT or bridged, also relates to cloud networking. In real cloud environments, virtual machines are connected through virtual networks inside data centers. So in simple terms, VMware is behaving like a small cloud platform. Your laptop acts as the data center server, VMware is the hypervisor, and your Ubuntu VM is the cloud virtual machine. This task helps you understand how cloud providers create and manage virtual servers on top of physical hardware. This Task 3 simulates identity and access management in the cloud. Different users represent different cloud identities. Here we are creating 2 new users. Commands used are sudo adducer admin cloud, which creates an administrator type user. In cloud, this represents an IAM user with higher privileges. Sudo adducer devuser, O1, will create a normal user account. In cloud, this represents a developer account with limited access. Sudo command allows administrative actions. This is similar to having root or owner access in a cloud account. Creating multiple users shows how cloud systems separate identities for security. This task demonstrates authorization and access control. Not all users should access all resources. Commands used here are sudo mkdir/clouddata. This command creates a new directory. In cloud, this is like creating a storage resource. The command sudo chown admincloud admincloud/clouddata will assign ownership of the folder to a specific user. In cloud systems, this is similar to assigning resource ownership. Command sudo chmod 700/clouddata will set permissions so only the owner can access the folder. This simulates IAM policies based on the principle of least privilege. The command su-dev user o1 will let you switches to another user account. This is like logging in as a different cloud user. The command cd/clouddata will attempt to access the folder. When permission is denied, it shows how cloud authorization works. This task reflects how IAM policies control access to cloud resources. Now let us move to task 5, where we simulate different storage types in cloud computing. In the cloud, there is no single storage solution. Different applications need different storage structures. That is why cloud providers offer object storage, block storage, and file storage. First, object storage. When you type mkdir_object_bucket, you are creating a folder named object_bucket. In real cloud platforms, this folder represents a bucket, such as Amazon S3. A bucket is simply a container that stores files. Next, when you type echo hello >_object_bucket/file1.txt, you are creating a file inside that bucket. This is similar to uploading a file into cloud object storage. Object storage saves data as separate files called objects. It is suitable for storing images, videos, backups, and documents. For example, when you upload a photo to a website or store a backup file, it is usually placed in object storage. Now let us look at block storage. When you type lsblk, the system lists block devices attached to your Ubuntu VM. This shows the virtual disk used by your operating system. In cloud environments, block storage works like a hard disk attached to a virtual machine, such as AWS EBS. It stores the operating system, applications, and databases. Without block storage, your virtual server cannot run properly. Finally, file storage. When you type mkdir/shared_files, you create a shared directory structure. Then, when you type echo shared test >shared_files/note.txt, you create a file inside that shared folder. File storage organizes data into folders and subfolders, just like what you see in Windows or Linux. In the cloud, this is similar to services like Amazon EFS, where multiple systems can access and share the same files. So in simple terms, object storage is for storing individual files. Block storage acts like a hard disk for your server, and file storage allows shared access using folders. Each type serves a different purpose in cloud computing. Now let us explain task 6 using a real cloud example. Imagine you are using an online shopping website like Shopee or Lazada. Thousands of users are browsing products at the same time. If the website is hosted in only one data center, and that data center has a power failure, the entire website will go offline. To avoid this, cloud providers deploy the same application in multiple availability zones within a region. For example, in AWS Singapore region, there are multiple data centers called AZ. The same website runs in AZA and AZB. In our lab, when you run Python 3-mhttp.server9000, this represents the website running in one availability zone. When you copy the folder using cpr object_bucket, backup_bucket, this simulates data replication. In real cloud systems, user data and application files are copied to another zone automatically. When you run Python 3-mhttp.server9001, this represents the website running in a second availability zone. If one server stops, the other continues serving users. In real cloud platforms like AWS, Azure, or Google Cloud, traffic is automatically redirected to the healthy zone. Users may not even notice that one zone has failed. This is how cloud providers ensure high availability and reduce downtime for real-world applications. Task 7 requires a short reflection of 5 to 7 sentences. Explain how your VM represents cloud infrastructure, how Linux users and permissions simulate cloud IAM, how the different storage types relate to the cloud, and the importance of reliability concepts like multi-AZ. This marks the end of the lab guide.